What if everything you know about space and time is wrong? What if the speed of light isn't constant? A mind-bending new theory suggests that it may not be. And if it isn't, well, we're gonna need to rewrite some textbooks. This is the Science Show. First, let us set the stage with a quick montage of a few billion galaxies spinning around, followed by a few melted clocks and light beams bending around an invisible mass. In our everyday lives, we don't really have reason to question that nothing can move faster than the speed of light, which is approximately 299,792,458 meters per second. That's also known as exactly 1 meter per second, squared times 186,000 miles, or about 186,000 miles per second. But even though we generally think of it as a constant, the speed of light isn't actually a constant. It's a definition. According to physics, it is exactly this number no matter what, so why should we even question it? Well, it turns out that there are some potential signs pointing us toward believing that it actually does change. That means that our current understanding of space and time may be totally off, potentially opening up a world of possibilities, including the possibility of traveling to other stars in mere moments. But let's start from the beginning. How do we get from here to here? Albert Einstein first came up with his theories of special and general relativity more than 100 years ago. His theories rely on the speed of light being constant. This is what allows us to sync up clocks across the universe and calculate things like distances to faraway stars. It's why physics equations look so weird, because they account for the fact that both space and time must stretch and shift in order for the speed of light to always remain that exact same value. And if the speed of light were to ever change, then space and time would also change. However, in recent years, scientists have come up with theories of the early universe that make predictions about what the universe would have looked like a few seconds after the Big Bang. One such prediction is the cosmic microwave background, or CMB, the afterglow of the Big Bang that's still floating out there in space today. The CMB was a big deal when it was discovered in 1964 because it confirmed some of Einstein's predictions about the behavior of light and the expansion of the universe, and scientists have been studying it ever since. One analysis of the CMB published in 2014 claimed to find evidence that the speed of light may have changed over the billions of years since the Big Bang, or more accurately, that the strength of one of the fundamental forces of nature called the fine structure constant may have changed. The fine structure constant basically determines the strength of electromagnetic interactions between charged particles like electrons. It's a value that we use in physics equations to help us predict how light will interact with matter. And the team that published this research argued that their data shows that the fine structure constant changed by roughly 1 part in 100 billion over the age of the universe. There has been some debate over the validity of this study, and attempts to replicate these results have fallen short. But a study published in 2022 claimed to find further evidence that the fine structure constant might not be constant. This study looked at distant quasars and found that the amount of light they emitted seemed to vary depending on how far away they were, which could suggest that the strength of light waves may change as they travel through space. Okay, now, what if it isn't constant? What if the speed of light actually changes over time or place? First of all, don't worry, your phone and your internet connection won't suddenly start feeling a lot slower. Most of the physics experiments we reused to doing rely on measurements within fractions of a second or at most a year or two, and any changes in the speed of light over those timescales would be too small for us to notice. So your iPhone is safe. But that doesn't mean that the speed of light can't change. It just means that the change is so slow that we haven't noticed yet. Or it could mean that the change is only noticeable over extremely long distances. Either way, if the speed of light did change, our experience of time would also change. Time for you would still pass at the same rate, but time for someone who was moving relative to you would either speed up or slow down. Maybe you've seen this before in sci-fi movies where a character gets on a spaceship and time on Earth seems to speed up while they're gone. They're moving relative to us at a high enough speed that the effect of the changing speed of light causes time to slow down for them. The size of the universe could also change if the speed of light changed. And yes, that means distant galaxies would no longer be as far away as we think they are. But would they be closer or farther away? Well, that depends on whether the speed of light got faster or slower. We know that the universe is expanding, meaning that space itself is getting bigger, and we know that the expansion is speeding up. If the speed of light remained constant but the universe continued to expand faster and faster, then the speed of light would appear to slow down relative to us. So if the speed of light slowed down, space would also have to shrink. In other words, galaxies would get closer together, which would be super convenient for interstellar travel. All of the physics laws we currently use would need to change too. Basically, if the speed of light isn't constant, then we'd need to figure out a whole new way of describing the universe. But that brings us back to the question, what if it isn't constant? How would that affect space travel? Well, we'd love to figure out a way to travel faster than the speed of light without breaking physics. Mostly because most of the nearby stars are close enough for us to ever visit them with our current technology, unless the speed of light changes. A lot of people think faster than light travel is impossible according to Einstein's theories. But Einstein's theories assume that the speed of light is constant. If the speed of light isn't constant, then all bets are off. Interstellar travel would become possible either by making the speed of light faster or by slowing it down. Of course, we'd have to figure out a way to do that, which would require a lot of energy, probably more than we currently have at our disposal. But at least it wouldn't break the laws of physics anymore. In theory, if we figured out a way to make the speed of light faster, it would also make time go faster, so you could blink and arrive at Alpha Centauri. But maybe slowing down the speed of light is a better option. If we slowed it down, time would also slow down for us. So you would stay relatively young while everyone else in the galaxy ages. Sure, you'd miss out on all the cool stuff happening back home, but you'd get to have all the knowledge and wisdom of a 100-year-old, while looking like you in your 20s. It sounds pretty great to me. And sure, if you wanted to travel to another star system, you'd have to wait around for a really long time until the universe expanded and brought the other galaxy closer to you. But you'd also get to watch that galaxy get closer and closer until it was right outside your window. Wait, hold on. I haven't even finished my coffee yet. Don't you want to hear the punchline? Here it is. Scientists are skeptical. Turns out not every physicist is convinced that the speed of light isn't constant. Many physicists argue that there simply isn't good enough evidence to say that it's not constant, and that the apparent changes could be explained by other things. For example, the fine structure constant isn't the only thing that could change. The gravitational constant could also change over time and space, which would affect how strongly gravity pulls on objects. There's also a limit to how precisely we can measure the speed of light. We know it to be exactly 299,792,458 meters per second. But even that level of certainty is only because we decided to define it that way. If we made it less precise, it could look like the speed of light was changing. So basically, physicists disagree about whether or not the speed of light is changing and how precisely we can measure it. It's also worth mentioning that if we did find evidence that the speed of light was actually changing, we'd have to reevaluate a whole lot of physics. But the idea that the speed of light might not be constant is intriguing, and it opens up some interesting possibilities. Maybe one day we'll figure out a way to control the speed of light or find a loophole in physics that lets us travel faster than light without breaking any laws. Until then, we can continue to explore the universe at the speed of imagination. So remember, if light speed isn't constant, the universe is stranger than we can imagine, and the future of humanity might just be faster than light. Hey, thanks for watching this episode. If you want to help support the channel, you can go to our support page,